Hi everyone, I am Rajitha, working as an assistant professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today, we're going to say about asymptotic notation and its properties in analysis of algorithms. So, introduction to asymptotic notation. Asymptotic notations are mathematical tools used to analyze the performance of algorithms as the input size increases. Instead of focusing on exact execution time, we study how an algorithm grows when the input becomes very large. This helps us understand long-term performance in real-world applications. Algorithms often deal with thousands or millions of data items. So, analyzing small input is not sufficient. Asymptotic analysis allows us to compare algorithm fairly and choose the most efficient one. Why asymptotic analysis matters? Asymptotic analysis is important because it is independent of hardware and programming language. The same algorithm may run faster or slower on different machines, but its growth pattern remains the same. It focuses on scalability, helping us predict how algorithms behave with large data set. Growth rates reveal the true efficiency of an algorithm. This analysis supports better decision making during algorithm selection and system design. And growth of functions inductions. When input size increase, some algorithms grow slowly while others grow very fast. Constant time algorithms take the same time regardless of input size. Logarithmic algorithm grow very slowly and are um, highly efficient. Linear algorithms grow proportionally with input size. Quadratic and higher order algorithm grow very fast and become inefficient for large inputs. Understanding growth trend help avoid poor design choices. Big O notation, upper bound. Big O notation um, represent the worst case performance of an algorithm. It gives an upper bound on the running time or space usage. This means the algorithm will never exceed this limit for large input. Big O ignores constant and lower order terms because they do not significantly affect growth for large values of input. Common examples include big O of 1, big O of log n, big O of n, and big O of n square. Big O is the most widely used notation in practice. And big O, omega notations. Omega notation describe the best case performance of an algorithm. It provide a lower bound, meaning the algorithm cannot perform better than this limit. Omega is useful for understanding the minimum resource required. And it is also important in providing that no algorithm can solve a problem faster than a certain limit. This helps establish theoretical efficiency boundaries. Next, theta notation. So tight bound. Theta notation gives the exact growth rate of an algorithm. It combines both big O and omega bounds. If an algorithm is both O g of n and omega g of n, then it is theta g of n. Theta is the most precise notation because It tightly bound the algorithm from both uh, above and below. It gives a complete picture of algorithm behavior. And little o and little omega notation. Little o notation represent a strict upper bound, meaning the function grows strictly slower than another. Little omega represent a strict lower bound, meaning it grows strictly faster. These notation are mainly used in theoretical analysis and research. They help compare algorithm more precisely when equality is not allowed. And the mathematical properties of asymptotic notation. Asymptotic notation follow important mathematical properties. Reflexive property means a function can bound itself. Transitive property allow chaining of bounds. Symmetric property applies to theta notation. These properties simplify complexity analysis and make comparison more systematic and reliable. And impact on algorithm design. Asymptotic analysis help predict performance before implementation. It guides algorithm selection based on problem size. It ensures scalability for future growth. It also identifies optimization opportunities by highlighting inefficiencies. Overall, asymptotic analysis transform algorithm design in a scientific and structured process. Um, this is the mind map for asymptotic notation, and asymptotic notation are essential tools in algorithm analysis. They help compare algorithm, predict scalability, and ensure efficiency. By understanding big O, omega, theta, and their properties, developers can design reliable and high performance system. Mastering these concepts is a foundation for advanced computer science and real world software development. Thank you.